Alright, hell yeah. So we have a two-part video. One, we're going to go over like, hey, this is the quadratic equation. You know what I mean? I guess we all know the quadratic equation to be x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. You know what I mean? And that's cool to memorize it, but this is the same thing. It's just massaged into this. But why I'm bringing this up is because this is the first and easiest place you can actually get the quadratic equation to solve for x. Like, hey, you just solved it. To go from here to here, you know, that's just a lot of massaging. So we're gonna show how to get this part, and maybe I'll leave it for another video to take this and go to there. You know what I mean? And and then we're going to apply it to a problem, because I've actually never done this. One is that, hey, we can just do a quadratic problem and then just use this, and then maybe use this, and then kind of compare. But that's what I liked about this, because I was running into so many problems using the quadratic, because there's way too many negatives. You know what I mean? And then I would really mess up the negatives. That was my biggest issue. And so it's just nice to have just another equation that's basically identical, but it's a different enough where, yeah, I can check my answer. But then I was just like, well, holy Toledo, you know what I mean? I solved this quadratic equation just from a generic, and so we'll go over that, from a generic what was it? What? Ax squared plus bx plus c is equal to 0. And then I was just like, okay, so we solve this, and then you know, it's just interesting, the light bulb went on. It's just like, oh, anytime I get a quadratic problem, I can actually just solve the quadratic problem without doing this generic, you know what I mean, this generic version. So that's what we're going to do. We're going to take this problem. This was floating on the internet, and it was just fascinating. Boat goes upstream and then goes downstream, and you know, 20k upstream, 20k downstream. There is some flow to the river, you know what I mean? So it's the boat can only travel max speed, let's say, the speed of the boat. So it's gonna take hell of a lot longer to get upstream, and then it's gonna come downstream pretty fast. But the total time is 4 hours. Sweet, river currents 3 kilometers an hour. And then, you know what I mean, this website just gives you this. This is where they started. It's just like, that's such a horrible place to start. I couldn't even figure out, you know, it's just like, huh, I guess that's what this equation looks like. And so we're going to see why this equation looks like that, and why you know what I mean, you should never start with something complex like this. Anyway, all right, so let's get to it. Okay, so we're going to solve the quadratic equation, just kind of in a general form. Now, the first thing that I do, you know what I mean, if you haven't done this in a while, is just like, well, definitely we want this just to be x squared. We don't want any term over here, so we just divide everything by a. And so if we divide this by a, just mentally before I write it down, this just becomes 1, and then we got x squared. But then we got to divide this by a and this by a. And then we can even divide 0 by a, but that's just still 0. Alright, so let's do, I guess, every step. Okay, so once we do this, now we got x squared plus b over ax plus c over a. Okay, the next thing is to get this constant over there. And so I probably could have done that in one step. I want to just use one sheet of paper for this. So I'm going to come over here, I'm going to go x squared plus b over ax. And then I'm going to leave some room, and then I'm going to go negative c divided by a. Because now, the general form of how to solve this is you want to get something like this. You want to take this and turn it into x squared, so you just have this on this side of the equation. And then, cool. And then this is gonna be like x plus something. You know what I mean? And then, well, once we get and this side of the equation will just be a constant. So we can take the square root of this, and then we'll take the square root of that, and then we can basically solve for x, because then we can just subtract that side. So that's exactly what this is. Hey, the square root of a bunch of constants, and then subtracting whatever was in this, you know what I mean, and then we get x. Okay, so when we get this, how I typically do kind of the FOIL is, hey, let's say, let's just throw the generic. Hey, I got something in here. So this generic is going to be like, how I do FOIL is just like, hey, this squared, okay, plus this squared, okay, and then plus, I'm going to do this times that. That's going to be x times that, but there's going to be two of them. Cool. So that's kind of how I do FOIL. Instead of, putting this term in the middle, I just do the easiest stuff first. It's like, heck yeah, this is going to be squared, this is going to be squared, and yeah, we can even do that. So just kind of generically, we have this. So typically people, what they do is they do FOIL like this. They do x squared plus, okay, now I have x this, and then I go, oh, and then plus this x, and then, okay, and then that squared. You know what I mean? But, I mean, if you have this, hey, you know you're going to square that. You know you're going to square that. And, so yeah, it's just kind of easier to do it that way. And then these two terms, when you multiply them together, you're going to double it. And if this is a negative, well, your x squared terms are always going to be positive. And then this term will be negative, because it'll be x times negative whatever that is, and then twice that. But anyway, but for our case, it's a positive. And so now I guess it is kind of tricky. It's just like, well, I guess you just have to know that, hey, when we multiply these two things together, we get this, and this should be double. You know what I mean? So I think even in math is just like, well, let's just guess, and let's guess wrong. So we're just gonna say, hey, this is x, and then let's just throw this in. This is just b over a. Now, like obviously there's not another x term, but we're just taking this, and then we're gonna square it. So let's do that the thing that I do. So I'm just gonna go x squared plus b over a squared, and then we got plus x times b over a, but we got two of them. So we got 2xb over a. Alright, now, and this might be just a touch confusing, because we are going to get this extra term. You're never going to get this. So with this extra term, we would always just add this extra term here and this extra term there. But we have to get these two terms to look the same, and they don't. This is just b over ax, and this is 2 times b over ax. So yeah, so when we do this, it's got to be x plus b over 2a, or just 1/2 b over a. And then we're going to square this, and now it'll come out just real nice. So we'll have x squared plus this term b over 2a squared. And then we're going to multiply these two together, so we got x times b over 2a, but we know we got two of them. Sweet. So then we get something that's just x b over a, and that's exactly what we see there. Okay, but we do get this extra term, so we have to add it to both sides of the equation. So we're going to go b over 2a, and we're going to square it there, and then we got b over 2a, and then we're going to square it there. So now, if we had this, then heck yeah, this just becomes this, and so we'll kind of write that down. We're going to go x plus b over 2a squared is equal to negative ca plus b over 2a, and then just this is all squared. Okay, now when we get it to here, we can square this. You know what I mean? We take the square root of this side. We can take the square root of this side, and that just kind of opens up this x plus b 2a, and then we're almost there. So we're gonna take the square root of that, and when we do, we have to do plus or minus, because I don't know why. Okay, and then so we're going to have x plus b over 2a. This is squared. And then we got plus or minus the square root of negative ca plus b over 2a squared. And you should always say that. Anytime where you're just like not sure, you're just like, yeah, I don't know. And then it's good to say you don't know, because then you'll be thinking about it, and that's very helpful. And I think it's because yeah, why is that? That's fascinating. Could we figure that out real easy? I'm gonna take a couple minutes. All right, this is super cool. Like every time I turn off the camera, I just take like almost a split second. So yeah, let's say we're gonna figure out why this is. So if we have 2 squared, cool, and then we take the square root of that, that's gonna be equal to oh, just a second. Oh, my bad. So we have this term x. Now this can be anything. It can be 0, it can be in positive infinity, negative infinity, but anyway. So what we'd have here is we would have x is equal to the square root of, let's say, 2, oh damn it. Alright, I think I got this. So we're going to have, this is just generically x squared. Just forget about that term. So you can see, like, sometimes the extra terms, just get rid of them. You know what I mean? Yeah, if you have a polynomial that's like x squared plus 2x plus 1, you know what I mean? Your x squared is, mainly, you could just simplify a polynomial and just say, hey, who cares? It's just an x squared. You just get rid of everything. At the end of the day, it's an x squared. So same thing here. So we have x squared, and now we're going to say this is equal to, we're going to say, let's see, where should we make this equal to? Oh, yeah. We're going to make it equal to 4. Okay, so if we solve this, we would take the square root of this side, and then the square root of this side. But when we do, we have to do plus or minus. Because, so let's take a look at this. If we had 2 squared, that would give us 4. But also, if we had negative 2 squared, this also, like 2 squared is just 2 times 2. Where negative 2 squared is negative 2 times negative 2. And this gives us positive 4. You know what I mean? So that satisfies the equation. So negative 2 was an answer. So x is negative 2, and x is 2. Cool. And yeah, this is just fascinating. All right, and we can even, maybe take some time to even graph this one out, because we have our x squared. So if we're saying, hey, this is just y is equal to x squared. Well, when x squared is 0, we go 0. When it's 1, y is 1. And then when it's 2, 2 squared is 4. 1, 2, 3, 4. So heck yeah. So we're doing something like this. So yeah, we just kind of have that classic quadratic shape. And here's our solution. At 4, when x is negative 2 and when x is 2, both satisfy that equation. And so yeah, that's typically what a quadratic is. It's like you're going to have 2 solutions. Now, when we use it for real world problems, especially when you're trying to find time, the kinematic equations are, hey, position is 1/2 acceleration t squared plus the initial velocity times t plus the initial position. And so if you wanted to find the position, if you wanted to find the time it takes for something like a projectile to go up and then down and then hit the ground again, you'll probably have to use the quadratic equation. There's times where you're going to use the quadratic equation to find that time, but just the nature of it, you're going to find a negative time. You're going to have 2 solutions. One's going to be a positive time, and one's going to be a negative time. And these aren't going to be the same, But the negative time just will be nonsensical. So you'll only really have kind of one true solution in that regard. So heck yeah. So I think That was good. I'm glad I took that pause, because anytime, like, hey, if I don't know something, you know what I mean? Well, you probably do. You just don't know, like, 100% why. Okay, hell yeah. And so we're basically there. We have, what we wanted to do is just get x. And hey, look at that. We can solve for x. We have x. And so we're just going to take this and then subtract this b divided by 2a squared. So we're going to say x is equal to plus or minus the square root of negative ca plus b over 2a squared. And then we have minus b over 2a squared. Alright, sweet. And so there you go. So there is, we just solved the quadratic equation. And let's, I guess we might as well solve this, you know what I mean? Like, you could do it, but it is kind of tricky to get it into this form. That was the whole reason of making this video, and I think I've already made this video once. But anyway, it's just like, hey, I just think when people make equations and then they kind of simplify them, they oversimplify them where you can't even tell how they got there, you know what I mean? And so that's kind of the bummer, because even here, it's just like, hey, you had this extra term, like that always stays, you know what I mean? So if you're going about doing the quadratic, or solving for the quadratic, heck yeah, you're going to get that extra b over 2a squared term, and that's where that's going to come in. Even this term, this first term is just spelled out, where we're going to have like, well, we're going to have c divided by a, and then get it to the other side. That's negative c divided by a. Cool. So you can just see how it's spelled out. We're going to get this over there. When we do this squared, we're going to have that extra term, and so we have to add that term to both sides, and so that's why this is a positive. And then we're going to take the square root of that, and then we got to do plus or minus, and we just went over why it's plus or minus. But then you're going to have this x plus b over a squared, and so, no, I'm sorry, like this was our trial. That did not work, so that didn't work. So we have this x plus b over 2a squared, and we take this, after we take the square root of it, we just have x plus b over 2a, so we can just subtract the b over 2a. And you can see why there's so many subtractions, you know what I mean? Hey, we had to get c over a over there. That's going to be a negative c divided by a. And right here, to solve for x, the last thing we had to do was subtract b over 2a. So you get that negative. All right, so let's rewrite this. So we have x is equal to plus or minus the square root of negative c over a plus b over 2a squared, and I think I might even be able to memorize this one better, minus b over 2a. I think so, you know what I mean? So, and for whatever reason, I strike out. Every time I use this equation, I do it wrong for whatever reason. I'm a little bit cursed with the quadratic because of the negatives. All right, so, and we want this to look like negative b plus or minus the square root of b squared minus 4ac. All right, all divided by 2a. Cool. So now, so this is a cool one too, because we have to get things out of this square root. And so particularly, anytime, this has all divided by 2a. So we can, if something on top is a plus b all divided by, we'll just do 2c, you could do this. You could be like, hey, this is a divided by 2c plus b divided by 2c. Okay, sorry to use similar numbers, but that's exactly what we're going to do here. So the first thing we can do is, sometimes we can work backwards from here and then forwards from here. So if we work backwards, we can see, hey, this is b over 2a. Plus or minus the square root of b squared minus 4ac, all divided by 2a. Sweet. So now we actually have two terms. Hey, and this, hey, we already got a term. Look at that. So we're doing pretty good. Now, they managed to get a 2a out of here. Okay, and so I think the other thing that we should do is FOIL this through. So if we say b over 2a squared, what is that? You know what I mean? And you can do this 100 different ways. You can say, hey, that's b the top squared divided by 2a, the bottom squared. So you can do that, or you can just see that this is everything's a product. There's no addition or subtraction. So we can just say b squared, 2 squared, a squared. So that's kind of a fun way to do it. And then we can say this is b squared over 4a squared. So I think that'll be very useful. So let's do that. So we have x is plus or minus the square root of negative ca. We have a plus sign, and we got b squared divided by 4a squared. Okay, sweet. So now, yeah, we're using that same thing of like, hey, we need to get the denominators to look the same, because the only way to actually get something out of the square root is if it's a product. So if I had the square root of 1 plus x, like I can't, and maybe I should slow down and think about, I'm just coming up with stuff on the fly, but I can't really get anything out of here. But let's say I had the square root of 4 plus 4x. Well, heck yeah. So now I can actually get something out. I said anything in a square root, or even like a, when you square terms. So let's do the same thing and say we have 4 plus 4x squared. Cool. You know what I mean? I guess it is kind of cool. It's like you should be looking for products. You know, you have this plus or minus, you know what I mean? That's no good. And so what you're trying to do is factor out stuff to get something looking like a product, because this could be 4, 1 plus x, and then it could be all squared. You know what I mean? So that is the same. And then since we do have two products here, heck yeah, we can do 4 squared, 1 plus x squared. So these are going to be the same. So this would be 16, 1 plus x squared. And let's just throw in a value on this. If we threw in 2 here, we would get 4 plus 8. That would be 12, and 12 squared is 144. So here, if we threw in 2, we would get 4 times 5, 16 times 5. Oh, are we going to strike out on this one? Oh, that's sweet. Yeah, I totally caught my error. What the hell was I even doing? So this was 4 squared and then 1 plus x, and this is all squared. Okay, so this is going to be 1 plus 2. That's going to be 3. 3 squared is 9, and we're going to get 16 times 9. Let's say I didn't know what 16 times 9 is. But let's say I did know what 3... No, I don't even know it. Holy, how would I do this? I think I would just do this as like, hey, this is almost 160. You know, that's 16 times 10, and just call it a day. Who cares? But I'm going to have less, minus 16. And so even this is just like, nah, it's too hard for my brain. Alright, sorry about that, ran out of juice. So even right here, 160 minus 16, I don't even want to think about that. So I'm just going to say it's 160 minus 10. And then, but I guess I got a minus 6. And then, oh, okay, I could probably do that, 144. Alright, so we get the same answers there. And, well, we just showed that if you, and then the same thing here. And don't, you know what I mean, if you want to, like, I think the square root can also fool you, but it's a good thing to have. You know, I mean, we kind of know what a square root is, but you can also turn this into 4 plus 4x to the 1/2. And now we have an exponent, and we have just an exponent that's a number. I mean, you could really turn this into 4 plus 4x to the 0.5. And now you just have a number as an exponent, and it's just a number. You know, I mean, just like you have 2 as an exponent, and it maybe makes it feel just a little bit more... I don't know, just familiar. But anyway, we're going to do that same thing. We're going to factor out a 4. So we're going to do 4 is 1 plus x. And then we have that, I don't know, this might be confusing. So let's keep it like this, since we're all used to the square root. But now what we can do is we have a product. So we can take the square root of 4 and the square root of 1 plus x. So that's what we're going to do. Square root of 4 and the square root of, we don't even need parentheses, but 1 plus x. Okay, cool. And we know the square root of 4, and let's keep going, you know what I mean? Because if we did it this way, which we were I was a little bit confused, but it would be the same thing as 4 to the 1 plus x, or all to the 0.5. well, let's do 1/2 for now. So this would be 4 to the 1/2, and then 1 plus x to the 1/2. No one does it like this, 4 to the 0.5, 1 plus x to the 0.5. But you could do it like that, and I guess you just need to know that 4 to the 0.5 is 4 to the 1/2, and 4 to the 1/2 is a square root. It's definitionally a square root. And even right here, what's 4 to the 1/2? Let's talk about that. So 4 to the 1/2 is oh yeah. So 4 to the 1/2 is the same thing as 4 to the 1. You know what I mean? And then this number goes over here. It's going to be 2 square. That's the what do they call this? The second root. Because if we had 4 to the 1/3, that's going to be 4 to the 1. But then we have the third root of 4 to the 1. And so that's just going to be the cubed root of 4. Alright, and hell yeah, let's do one that actually makes sense. So 2 to the 1/3 is going to be 2 to the 1. That's just 2. But then we have the third root of, cubed root of 2. So we have cubed root of 2. And I bring this one up in statics, because if you have a triangle, yeah, I guess this would be kind of cool. If you have a triangle that's 1 plus 1, like, heck yeah, this is the square root of 2, and because of Pythagorean's theorem, a squared plus b squared is equal to c squared, so this c is going to be a squared plus b squared square root that, and then their a term is 1 squared, that's going to be 1, b squared, that's going to be 1, so we have the square root of 1 plus 1, that's 2, cool. But if we have a box, because this one, that's if you're used to just doing things in 2 coordinates. But if you're going to do things in 3 coordinates, hey, starting from here, let's say this is our x, this is our y, and now I guess we just do this as our z. Yeah, so we could do this. We could say this is our x, this is our y, and then this is our z. So if we want to take a distance from here to there, oh, that's not a very good drawing. Sorry about that. It'll just make sense more visually if we go from here to there. So if we go from there to there, and this is 1, this is 1, and this is 1, and I guess I don't want to really get into it, but this line is the same thing as a squared plus b squared plus c squared is equal to d squared. And this is our d right there. So d is the square root of a squared plus b squared plus c squared. And I'm not going to prove it, but it's so similar that you can kind of trust it and then memorize it. You know what I mean? So heck yeah. So this is going to be the square root of 1 plus 1 plus 1, and that's 3. So this distance, crossing a cube, the diagonal distance is the square root of 3. And so the square root of 3 is a good one to memorize. It's just 1.73. I think it's 1.773. Whoops. Oh, my bad. No, I don't even know what the square. No, this is the square root of 3. Okay, yeah, that's the square root of 3. So yeah, it's good to this would be 3 to the 1/2. My bad. That's not going to be 2 to the 1/3. I don't know anything. I don't know anything useful for this cubed root of 3. And I'm just saying that so the universe throws me something useful for the cubed root of any number. You know what I mean? That would be pretty satisfying. Okay, so yeah, we figured, yeah, so that was just a huge tangent. So we're going to have to maybe get some sheets of paper. Alright, hell yeah. So that was a good segue, because now we can figure out what we need to do here. So we don't have any products. We can't factor out a c, we can't factor out a b squared. And worse, these two things aren't the same. So this comes up a lot where you're just like, hey, let's get these things to look the same. And that'll come up, I think, in our problem. Like this. I don't see an x squared equation, but to get these denominators to look the same, we have to make sure that they're the same. And the easiest way to do that, so we can just actually start in on this one, is to multiply this by x plus 3, because that's over there. And then if I do that to the bottom, I got to do that to the top. So heck yeah, this does not change the equation. It's basically like multiplying by 1. And then over here, we would do x minus 3, and then x minus 3. So now downstairs, we're going to get something, the denominator is going to be the same, but it is going to be x, so we can just do this. X times x is x squared. And then I like to do these next. So then 3 times negative 3 is going to be negative 9. And then do the other two. We're going to have x times 3, and then 3 times, holy Toledo. You're going to have x times negative 3, and then 3 times x. Oh, maybe I should FOIL this through. Yeah, maybe I do not know what I'm talking about. Because yeah, this isn't a classic like x minus 3 squared, so I probably can't use the same strategy. So we're just going to do classic FOIL. We got x squared, so that's what I did there. Then I have negative 3x, and then I have plus 3x. Oh, cool, so those go away. Yeah, I totally forgot. I don't do a lot of algebra. Okay, and then we got negative 9. So cool. So now we just have x squared minus 9. And now even this, if I ever see this come up again, I can be like, oh, I remember that. If I have x squared minus a number, like it could be any number. And then I could get it into a form that's x plus something, x minus something. So that's cool. Alright, so that's what the bottom's going to look like. We have x squared minus 9. And then the top is going to look like, and we can just, you know what I mean, I guess just for now, we got x plus 3 times 20 plus 20 times x minus 3. And then we could FOIL that. Alright, let's get back to our problem. So what we want to do is get the denominators the same. So, you know what I mean? If this, let's do a different problem. If this denominator said 4b squared, like maybe 1 divided by 4b squared, and this had 1 divided by a, if I had to get the denominators the same, then I would have to multiply this side by 4b squared. And then I would have to multiply this side by a. And then both the denominators would be like 4b squared a or 4b squared a. So sweet. But we don't have, we at least have one term that's the same. So over here, all I have to do is multiply by 4a. Because a times 4a, that's going to be 4a squared, and that's what I have over there. And I don't have to multiply this side by anything. Okay, so sometimes the simpler, kind of the harder, you know what I mean? Because if these two terms were totally different, we just showed that, hey, you just multiply this by that, and that times that. Now you could do that, like you could say, hey, I just want to go a times 4a squared, and then this 4a squared times a. But you would have to do the top that way. Yeah, let's do that, because no one's ever going to do that. So we have 4a squared up top, and then we have just multiply by a up top. So up top we have negative c 4a squared, and then we have a times b squared. Okay, so yeah, I don't know why I'm doing this, but whatever. So we have, let's get all the terms kind of the same. So we got negative, so we have negative 4a squared times c divided by 4a cubed plus ab squared divided by 4a cubed. But even right here, you can see that we could factor out an a everywhere. And so let's do that. So let's not do what I just did, and just make it simple. And so we're just going to multiply the bottom by 4a. So we're going to have negative c a multiply by 4a on the bottom, multiply by 4a on the top, and plus b squared divided by 4a squared. Cool. So now our bottom looks the same. So let's just go over here. And so we're going to go, and I think it's good too, you don't have to rearrange the letters. But you could get the constant in front, so we're going to have -4. Maybe do the a term, just go in alphabetical order, then the c term, and then divide by 4a squared. Okay, now we got plus b squared divided by 4a squared. Cool, and if we go back to the square root, hey, this thing was all under the square root, and now you can see that we have a common denominator. So sweet. So we can be like 4ac plus b squared, all divided by 4a squared. And this is the square root. So finally we have something that's all alone, that's not just like an addition or subtraction. So here we can use that kind of that rule that, hey, we can still take the square root of the top. And if we want to get even closer, hey, we already identified we had the b squared term, minus 4a. So let's just flip-flop these right now. And so we got b squared minus 4ac. Oh, heck yeah, now we're feeling pretty good. And then this is all divided by the square root of 4a squared. Cool. And we can use that same product, I don't know if it's like a product rule or whatever, but you can, hey, if we do have a product of things, we can take the square root of 4 times the square root of a squared. Cool. And I mean, even if you wanted to do it, you could say that 4a squared is 4a times a, and take the square root. That's going to be the square root of 4 times the square root of a times the square root of a. We just know, just like the square root of 2 times the square root of 2 is 2, that this is square root of 4, square root of a squared, and heck yeah, this is going to be the square root of 4 times a. So once we do this, it's technically not out of the square root yet, but we're going to have square root of 4 times the square root of a. That's just 2 times a. So heck yeah, now it's officially out of the square root. So we have this term was the square root of b squared minus 4ac, all divided by 2a. Okay, and all we were doing was focusing just on this term right here. You know what I mean? We went, once we started with saying, hey, we can just take this negative b divided by 2a, and this is plus or minus this divided by that. And so that's basically what we have right now. We have taken this term and said it's b squared minus 4ac divided by 2a. But we still have this term over here, minus b, plus or minus, and we still have this, minus b divided by 2a. Cool, so it looks like this, but now let's just flip it around so it, you know, that's the crazy thing, is like at no point should this have ever been in front of the square root. That's my biggest beef with doing this quadratic equation, because if you start from here, you're going to get the negative ca over there, and then you're going to figure out how to square that part, and then you're going to have to add this over there. I guess, then you add that, and then you take the square root of it, and then you have to subtract this part. So at no point would I actually put that subtracted part in front of this. You know what I mean? So it's just kind of fascinating that there's just multiple things about this quadratic that just from a mathematical, just from an algebra standpoint, no one would do. And so that's what I'm pointing out. It's just a little bit, I guess, more confusing. Okay, so all right, so where are we? So we have this, so x is equal to this, and now you can see, oh, if our denominators are the same, then we can just do the addition or subtraction on the top, and then just all divide it by 2a. But we said we were going to do that one step where we're going to get this over here. So we got negative b over 2a. plus or minus the square root of b squared minus 4ac, all divided by 2a. And so now we can just do that. We have a common denominator, so we can just add the tops. So we have negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Alright, hell yeah. So we did it. And I just think, I don't know, I just enjoy that I can use this and I can get there fairly fast, and I can use it as a check on reality of the actual quadratic equation. Alright, so let's tackle this problem. Alright, hell yeah. So we have the riverboat cruise problem. You know, I mean, this was floating around on the internet. And so we have a boat that travels upstream against the current. So it's going to go slow as. But it goes the same, it goes 20 kilometers. That's pretty impressive. You know what I mean? So it starts at the marina of a river, I guess. Goes upstream 20 kilometers and then decides to turn around. Goes downstream. But then it's going hella because it's going with the current, and I mean, this we're just going to say the motor is going to be maxed out. You know what I mean? The boat only has one speed. It's like off or on. Cool. And that total time took 4 hours. Now I think a good idea for this problem is to I mean, if you can get to the equations, cool. So actually, let's do that. But the other thing to do is just kind of guess. You know what I mean? We'll just like choose a number. And then the first thing that I kind of came up with is that, okay, the river current is this isn't very good, but it's 3 kilometers per hour. That's the river current. And if the boat is going to go upstream, I mean, the first obvious thing is the boat speed has to be greater. So I'm just going to write that. The velocity of the boat has to be greater than 3 kilometers per hour. And in our guess, you know what I mean, hey, just choose 4. You know what I mean, choose 4 kilometers and see if you can do the problem and see how many hours. But for this problem, it says it takes 4 hours, 4 hours total. Shouldn't be a hyphen. But anyway, all right. So you got 4 hours total. So now, what I like to do is, especially speed, and I would do this, like, if I was, people are like, hey, you should do some electrical engineering problems, and I probably should, but I would do the same thing. I would write down the units. You know, the units are the equation. So, one is we're dealing with speed. That's going to be, let's just say meters per second, classically, kind of, and then we're going to say we're going to be dealing with time. That's going to be in seconds. And then we're going to be dealing with distance. That's going to be in meters. So even from our problem, hey, we have time of 4 hours. We have a distance of 20 kilometers up, 20 kilometers down. We have a river current speed of 3 kilometers an hour. We're going to have a boat speed. Cool. So now we can just, if we use the units as the equation, like let's say I do know my velocity. It's meters per second. And then, and I do know my time. Cool. Because, I mean, one thing is like you know that if you left the marina, I mean, this is also really good. You know what I mean? This is simplifying a problem just to even wrap your mind around it. So I wave goodbye. 4 hours later, they say they went a total distance of 40 kilometers. You know what I mean? So let's figure out what their boat speed is. So if I have a distance of 40 kilometers, and then I have a time of 4 hours. Cool. What do I do to these units to get, you know what I mean, meters per second? And I love this because it's like almost like Blue's Clues. You're just like, well, no duh. I guess for whatever reason, I take meters and divide by seconds. And I'm just using meters and seconds in a classical, you know what I mean, just like that's typically what we do, meters per second. But anyway, for our problem, we're going to be dealing with kilometers and then hours. Cool. And yeah, and hopefully that wasn't too confusing. So I like to use kind of these, but you could say, hey, we have a velocity in kilometers per hour. So that's 1 unit. We have a distance in kilometers, and then we have a time in hours. These are the 3 things that we're going to be doing. So I can do that same thing I just did of saying, hey, we're going to go a distance in kilometers of 40 kilometers. And we're going to have a time in hours, and that's going to be 4 hours. So what do I do to these two numbers to get the speed, the average speed, during the trip? And that's not of the river or the boat. That's just kind of the average speed, this, you're going. Cool. Well, obviously speed is in kilometers per hour, so I guess I would take the kilometers that I traveled divided by the hours it took to travel. And hell yeah. So now, I think this is pretty cool, kind of the units or the equation. I dig it. And so we're going to have 40 kilometers is equal to, or divided by 4 hours. And we're going to have an average velocity of 10 kilometers per hour. So if if I'm just able, and this is average velocity. So if I'm able to just go 10 kilometers an hour, whether it's on a bike or in a boat or in a car, doesn't matter, and I travel for 1 hour, well, look, check it out. I went 10 kilometers. If I travel for 4 hours, I went 40 kilometers. So already right now we kind of have an idea of and check this out. So now, hey, that's going to be the average velocity of the boat. And the river current's 3 kilometers per hour. So I don't know. I mean, wouldn't that mean that, I don't know, maybe on the up journey? But this is going to be wrong. But it's just good to just throw out things that your brain wants to think. You know what I mean? Well, doesn't that mean just my average speed up? So we're just going to say my average speed up. Maybe at 7 kilometers per hour. And then my average speed down is 13 kilometers per hour. Maybe that'll work. Probably not. And so we'll keep that in mind. But now what you'd want to do is actually use the units and get some sort of equation. You're trying to get, obviously it's a quadratic equation or this, these problems require algebra. And so you have to get kind of a couple equations, if not 3 for this one. All right, so now we're just going to say, well, I don't know, maybe we should kind of play around with the numbers. You know what I mean? So what I wanted to do is just say, well, let's say the boat can go 4 kilometers an hour. So if the boat can travel 4 kilometers an hour, but the river is going upstream, the river is going 3 kilometers an hour that way. So that means that the speed of the boat can only travel 1 kilometer an hour. So let's do that. So we got 1 kilometer per hour, and it has to go a distance of 20 kilometers. You know what I mean? So even just right here, it's just like, oh, hell yeah. Like, I just mentally see that. 1 kilometer an hour, I got to go 20 kilometers. And if you want to use the units or the equation, we have kilometers per hour, and then we have a distance in kilometers. And then here, this was kind of, I make this mistake all the time. When I say I have a speed of 1 kilometer an hour and I have to go 20 kilometers, how long is that going to take me? I think just intuitively you're like, well, hell, 20 hours. If I'm only going one of those in an hour and I got to go 20 of them. But then when we look at the units or the equation, we don't multiply them because the units would say we would have kilometers squared divided by hours, and that makes no sense. So what do we do to these two things to get hours? And this is probably the only tricky one. You know what I mean? We got to take kilometers divided by kilometers per hour. So the kilometers will cancel, and hell yeah, time pops up upstairs, and so that gives us hours. So we would have taken 20, let's do it, so we got 20 kilometers divided by 1 kilometer per hour. Cool, so this gives us 20 hours. Okay, hell yeah. And then you can just easily see that, they say we did this trip in 4 hours, so that is hella not our speed. We can easily go more than the boat. The velocity of the boat is not 4 kilometers per hour. So let's pick just something kind of nice. Let's say the velocity of the boat is 13 kilometers an hour. And so on the way up, we're going to be able to go 10 kilometers per hour. You know what I mean? If the boat speed is 13 and the river is going 3, we're going to be averaging 10 kilometers an hour upstream. 20 kilometers, same thing. We're going to take 20 divided by 10. That's how you do it. Even though mentally you're like, hell yeah, 20 kilometers an hour and I got to go 20 kilometers, it's just 2 hours. I don't know. It's just weird how that just makes, humans are just very good creatures when it comes to speed. We drive all the time. And this is probably the easiest relationship to get. But it's just fascinating that you're going to take 20 divided by 10 to get those 2 hours. So heck yeah. So you're gonna go upstream for 2 hours, and then on the way down, well, you already know our problem is not going to work out because going upstream should have been slower, and then going downstream is going to be hella fast now. So if we go at 16 kilometers per hour, that's going to be the 13 that we thought plus the speed of the stream is 3, and we only have to go 20 kilometers. I don't know, like that's literally, it looks like it's going to take 1.5 hours. You know what I mean? And we could figure out what that does take. That's going to be 20 kilometers. Now that we're good at this, hey, we divide by 16 kilometers per hour. Kilometers cancel, hours pops up upstairs. And let's see if I can do this one. 20 divided by 6, that's 10 divided by 8. And no, I'm just going to give up. So 10 divided by 8, and that's 1.25. Oh, I probably could have done that. Was there a way that I could have done that? You know what I mean? Couldn't I just said, oh, this is fascinating. 10 divided by 8. I never knew this. Holy Toledo. 10 divided by 8 is just 8 divided by 8 plus 2 divided by 8. Whoa. See, this is where I'm learning like at rocket speed. Just stuff like that. Stuff where it's just like, no, I can't do it. Well, say you can't, and then then do it the fast way, and then go back to be like, well, could you have done it? That's the way you're going to get good at anything. You know what I mean? You can do that with the math. That's what I want to do with the Math Olympiad stuff. All that stuff is probably too much problem solving for me, but I've been never introduced to it. So I should just cheat the hell out of it and then just see what they're doing. And then, heck yeah, the next time I come across those problems, I'll just be good to go. Alright, so sweet. So we could have saw that this was, and then 2 divided by 8, that's 1 divided by 4, so we could have easily said that's 1.25. So we got 1.25 hours, and that only took 3.25 hours total. So that was not the right answer. So we must be going a little bit slower than 10 miles an hour. So now, let's not use nice numbers, but let's just try to guess. So I'm just going to guess, I don't want to underguess. I was going to guess 9. I think it's between 9 and 10. So let's do the harder one and guess 9. And so I think, I bet you that's too slow. So if we say the boat has a speed of 9, it has to go against the river. So we're only going to have an upstream speed of 6 kilometers per hour. We're going to take 20 divided by 6 kilometers per hour. And we can see that our units cancel. So we have 20 divided. Hey, let's not do this. So we have 6 times 3 is 18. So that's going to be 3. That's going to be 18 divided by 6, which is 3 plus 2 divided by 6. Oh, sweet. So now we're on a roll. Hey, this is 3. This is going to be 3.33. Booyah, 20 divided by 6. And I've done this one a couple times this week, so that's just going to be super helpful. I dig this. Okay, so we have 3.3. And, so we better be going hella on the way back. And we're only going to go 9 plus 3. We're only going to be going 12. And we got to do 20 divided by 12. See, we're going to use that same trick again. Or probably not. But this is going to be 12 divided by 12 plus 8 divided by 12. And that's going to be 1.75. So that's how many hours on the way back. 1.75. Oh yeah, this is the 5-hour mark. So yeah, I think it's going to be 11. Probably 12. Hey, yeah, let's say our speed is 11. So if our speed is 11, on the way up, we're going to be 11 minus 3. That's 8. So we have 8, and we're going to be doing 20 divided by 8. This is 20 kilometers divided by 8 kilometers per hour, or upstream speed. So again, this is 16 divided by 8 is 2. plus 4 divided by 8. So this is going to be 2.5 hours up. And then on the way down, we're going to be 11 plus 3. That's going to be 14. So we're going to do 20 divided by 14 kilometers in 14 kilometers per hour. Kilometers cancels. I don't know what 20 divided by 14 is, but using my cool trick now, we got 14 divided by 14 plus 6 divided by 14. Ooh, still don't know what that is. Yeah, what do you do when you get a difficult one? This is going to be 3 divided by 7. And then I think you just say, hey, I don't know 3 divided by 7, but I do know what 3 divided by 6 is a bigger number. That's the first thing. 3 divided by 8 is the smaller number. So I think putting them in order like this, even though it's like it looks like it's reverse, is a very good thing to do. And then even this. Okay, so I know what 3 divided by 6 is. That's a half, so that's going to be 0.5. 3/8. See, even that is just like, I don't know what an eighth is. So I'm just going to say, hey, I do know what a quarter is. That's 0.25. And then how do you divide 25 by 2? Well, that's like dividing 24 by 2. That's like 0.12. But then you have to divide the extra one as 0.125. I don't know. So I definitely know. I do that one a lot. 1/8 is, so I got that one down. 0.125. That's a good one to mentally get down. Multiplied by 3, well, that's going to be 0.375. Okay, so I have 0.375 and 0.5. So 3/7. It ain't going to be linear, but it's fairly close. You know what I mean? So I could just say, hey, this is about 0.4. And is it 0.44? Or is it just like 0.42? I forget. You know what I mean? Hey, what is 1/7? I thought let's do 1/7. 1 divided by 7 is 1/7 is 0.1428, which is so weird because that's just like 7 times 2. 2 times 7, and that's 4 times 7. So 0.1428. Yeah, I always thought there was something cool with 7s. Okay, so what's 2 divided by 7? That's 0.286. That's probably a harder one. Yep. So I don't know what we do there. 7 times 8 is 56. Yeah, it's pretty close to you know what I mean, doubling it. 14. 7 times 2, and then 7 times 6. So it's 0.14, and then 0.56. That'll get you fairly, it's 0.28 times 0.56. So that's, what is 3 divided by 7? 3 divided by 7 is, what's 42? Oh, this is interesting. 7 times 12 is 84. And then 7 times 6. Oh, that's interesting. So 7 times, 7 3/7 is, this is fast. I don't know why this is, but it is fascinating. The decimal is going to be 6 times 7, which is 42, and then 12 times 7, which is just double it, so it's 84. Oh, fascinating. But anyway, so heck yeah, and was my guess fairly close? 0.44, 0.442? Yeah, so you should always use your guessing skills just to be like, hey, do I remember this one? And sometimes it's locked far away in your brain. You've seen it once, but you're just like, hey, just guess. And now we just really honed in that. Now I'm probably going to forget this tomorrow, but you know what I mean? Hey, our initial guess was fairly close. That was pretty sweet. Now, what are we doing? So we were saying that on the way up, it's going to take 2.5 hours. And then on the way down, it's going to take 1 plus 3/7. So it's going to take 1.44, or yeah, what did we say? 1.42, 1.43 hours. Hey, that's pretty close. So now we know. And now let's overshoot, because I guess, so that was at 11 miles per hour. At 12 miles per hour, I bet you that's too much. You know what I mean? And then we're just good to go. So then when we do the quadratic, then we know that we're going to get an answer between 11 and 12. And then that answer you could probably bet your life on. You know what I mean? So that's the cool thing about finding, I think this is called throwing numbers at the problem is, I mean, it has like its own terms. Like there's like Newton and Euler both came up with methods of doing this. I mean, your like solvers on your calculator do it just more efficiently. They use, you know what I mean? They use calculus and derivatives to actually hone in on the answer. But we're just honing in just our way. So if we do 12 kilometers per hour minus 3, that's going to be 9 kilometers an hour up. 20 divided by 9. Heck yeah, I like our style. Is 18 divided by 18 plus 2 ninths. Now, I don't know what 2 ninths is, but I for sure know what 1 ninth. That's like 0.111. So 2 ninths is 0.222. That's pretty cool. So now we have 1.222. This is, I feel like that's totally wrong. Yeah, what did we do wrong? Because if we have a speed of 12, that's going to get reduced to 9. And it should take hella long going up. That's interesting. Yeah, what are we doing wrong now? Let's go back to 11. If we had a speed of 11 kilometers an hour, we'd have to subtract 3. That would be a speed of 8 kilometers. And then so we would have 20 kilometers divided by 8 kilometers per hour. Maybe we just totally royally messed up already. So this was going to be... oh, no. This is 18 divided by 9. No, it's 2.2. Yeah, I knew I was pretty close. I just didn't know why I was making that error. So on the way up, it's going to take 2.2. On the way down, it's going to be 12 plus 3. So we're going to be going 15 kilometers an hour. We're going to do 20 divided by that. And again, what's the units? Kilometers. 20 kilometers divided by 15 kilometers per hour. Kilometers cancels. Hour pops back upstairs. Oh, this should be an easy... Well... yeah, this should be an easy one. So we got 15 divided by 15 plus 5 divided by 15, which is 1/3. So on the way down, we got 1.33. So we're going to have 1.33, and this is going to be too little. So this is going to be 3.5. So this is going to take 3.5 hours, and if we went at 11 kilometers an hour, what did we say that was going to be? We said that was going to be 2.5. Oh, no, we were undershot anyway, so I'm going the wrong direction. My apologies. So at 11 kilometers an hour, we were too slow. It took 2.5 hours to get up and only 1.43 hours to get back down. So our answer has to be just a little bit faster than 11. No, it has to be a little bit slower. 11 kilometers, so it's holy hell. So 11 kilometers an hour was too slow, but it was for sure close. So I think our answer is going to be like 10.8, 10.9 kilometers. That's going to be the speed of the boat, 10.8 or 10.9 kilometers an hour. Now, this is a really good, useful strategy because you'll probably learn more about the problem mentally. And I consider the actual algebra to be very circus trickery. You know what I mean? It's just like, well, it's cool and it's very useful for solving like algebra. My brother just got me a linear algebra book, so hopefully I'll be doing some problems out of that, because he was saying, hey, if you learn linear algebra, then that's going to be the foundation to learn like quantum. Like everything is leading the way in quantum physics comes from a strong understanding of matrices in linear algebra. Like there's just no getting around that. And even just kind of watching a couple lectures, you know what I mean, that are over my head is just like, yep, I don't even know how to put together a matrix. But you know, you just have to. You just have to do it a couple times and then, you know, see what you're doing, and then you know what I mean. And it's fairly straightforward. If we did it, it would be like 1x plus 2y is equal to 3, and then we would have 5x plus 4y is equal to 4. One way to do it was just to be like 1, 5, 2, 4. This was from first chapter. Just draw a line right there and do 3, 4. You know what I mean? That's where I'm getting. Obviously, you should probably do it. I don't know. Yeah, so it's oh, now I see what you would do. You would be 1, 5, 2, 4, and then you would have probably like this, x, y, and then you would have equals to 3, 4. Probably something like that. I don't know. Yeah. So it's fascinating. And this can only go to there, and this can go to there. So if I had 3 of these columns, 1, 2, 4, 5, 7, 8, and I had x, y, z, then this has to be 3 deep, like 1, 2, 3 deep, and this would give us 3 different values too, 4, 5, 6. So even just like that, taking the take home, like, hey, like, do you know anything? And you're probably like, no, I don't know anything. And then you're just like, well, let's just figure it out just like that. I always try to think like I'm on a desert island and I have no more access to anything, and I still want to, you know what I mean, forge the way. All right, hell yeah. So now we're back, and we know the answer is going to be a little bit less than 11. So now what I like to do is like, hey, try to do that same thing without writing anything down. So we said that if we had like 10, a speed of 10, we were going to subtract 3. Cool. And then you can kind of see like, oh, isn't they're saying the boat speed is 10 and we subtract 3. And then even from their equation, it's just like, whoa, we see one piece of it. Cool. All right. So, and then once we have 7 kilometers an hour, we're going to do 20 divided by 7. And you're just like, whoa, that's exactly what they just did. 20 divided by 7. You're like, oh, now I see that. You know what I mean? So it's so weird that just intuitively you can know what's happening with speed. And then do the numbers in your head, whether you multiply or divide or add or subtract. So sweet. That's going to take, and we're going to store that as alpha t. And then on the way back down, we're going to say, hey, we have 10. But now we're going to go with the current. That's going to be plus 3. Whoa, that is exactly what we have here. So now we have a speed of 13 kilometers down. We're going to take 20 divided by 13. Sweet. And I'm going to store that as actually alpha s. I like to do alpha t, and then other times like this direction, alpha t, alpha s, alpha r, if I have like 3 different times, but alpha s. And so that's going to take 4.39 hours. So that was hella slow. And so, but now you can just do this thing real fast. Like, so we just said 11 was hella close, and 10 was pretty far away. So we could just go to the middle. That's kind of like the Newton method, is just like, we'll just kind of go halfway. I mean, I think one of the methods is just like, we'll just go halfway. I consider that kind of like the mountain climber approach. I think there was the Price is Right show where you kind of had to guess, and you know what I mean, and it would show how far away you were from the price, and you were trying to narrow it down. Sweet. So let's just say, hey, I think it's going to be pretty close to 10.8. You know, I think that's even too slow. So we're going to do 10.8. So 10.8 minus 3. Sorry. 10.8 minus 3, and then 20 divided by that answer. Cool. Stored as alpha t, and then we're going to have 10.8 plus 3, and then 20 divided by that. Store that as alpha s. So now alpha t plus alpha s, and ooh, we get, oh, so we were we too fast? No, we were too slow. So 10.8 was too slow, and so now we're going to do 10.85. Because I even think 10.9 is going to be, so heck yeah. So I'm going to store this as x. And now I can just do like, hey, x minus 3, and then 20 divided by that. And you can see how I could even do this step all in one now. I'm going to store that as alpha t, and then I'm going to have x plus 3, and then 20 divided by that. Store that as alpha s. And now I'm going to go alpha t plus alpha s. Ooh, so that was a little bit fast. And so that was a speed of 10.85. So now I'm going to go 10.84, store this as x, and I'm just going to try to do it all in one go. I'm going to say, hey, the speed up was 20 divided by x minus 3. So that's my time there. And then I'm going to go, on the way down, it's going to be that 20 kilometers divided by x plus 3. I'm going to store that as alpha s. So we have alpha t plus alpha s, and that's 3.96. So this was too fast. We did it too fast. We didn't do it in 4 hours. So that's the other part of problems, just like, well, we got a lower number for time. Does that mean that this value of 10.84 needs to be higher? Well, no, because this speed was too fast. We got there in too short of a time. It took 4 hours, not 3.996. So now we can use that. We can know that we need to go a little bit slower. So we got 10.8 for, And we're really close. I'm even just going to guess. So sometimes using your intuition and just guessing. 10.847, I'm going to store that as x. So 20 divided by x minus 3. And now I can just do it all in one go. Plus 20 divided by x plus 3. And so that's 3.93. And so, oh, so that was actually worse. So I needed to take a pause, see what I need to do. Alright, hell yeah. So we're back and took a little break. But yeah, so I see my error because I think this 3.996 was with a slower velocity of 10.47. So again, we got there faster. So we need to reduce this. So we need 10.837. So that's what we're going to do. We're going to go 10.837, store that as our x value. And now we're going to go 20 divided by x minus 3 plus 20 divided by x plus 3. All right, perfect. And so, hey, we're getting a little bit, but we need to slow down just even a little bit more. So we're going to go 10.834, you know what I mean? And then just bring up this equation again. Oh, so we need to slow down actually a little bit more. So how about 10.82 stored as x? Bring up the equation. Okay, so that was too slow. So then we're going to go 10.825 stored as x. All right, so that was still a little bit too slow. So we're going to go 10.829 stored as x. Okay, so that's too slow. So 10.832 stored as x. Okay, so that was too fast. So 10.831 stored as x. So that was still too fast. 10.83 stored as x. Okay, that's too slow. So 10.8305 stored as x. Okay, so that is too slow. So we're going to go 0.09 stored as x. Okay, so that's too slow. But if we do 10, I think that's too fast. Yes, that's interesting. So we're really honed in where this is too fast, but 0.9 is too slow. So we even got to go 0.98. You know what I mean? And so that's too slow, but 0.92 is too fast. Okay, so see how we're just honing in on the answer? You know what I mean? So this was too slow, so we're just increased it. Whoops. And we'll throw a 3 right here. And that was too slow, so we're going to throw or just throw a 4 right here. Okay, too slow. 5. Too slow. We're going to go 8. Too fast. And then a 7. Too fast. Whoops. And then a 6. Too fast. And then a 5. Alright, so that was too slow. So now, I mean, yeah, so I mean, how many digits do we want? So we know our answer. The boat speed is going to be 10.883. You know what I mean? Or just 10.8 miles, kilometers per hour. You know what I mean? And even doing the 0.8 is kind of ridiculous. Hey, we're going 11 kilometers per hour. That's kind of our average speed. Okay, so hell yeah. So now what we're going to do is well, I don't know. I don't know what we're going to do. Because I think we should try to tackle this problem from just like an algebra standpoint. From an algebra standpoint, I would say, you know what I mean? Like I would say, hey, if it took 4 hours total, we have like a time going up, and then we have a time going down. The time going up is going to be, you know, some relationship between our speed, the velocity up, and we'll just say the distance up. So I know that these two are related, and that's where I kind of go back to the units are the equation, because velocity is kilometers per hour, distance is in kilometers, and so to get hours out of this, to get how this would be proportional to the time going up, we definitely have to see that we have to take this distance divided by the velocity. And that will be the time going up. Cool. And then we can say that the velocity going up is going to be the velocity of the boat minus the velocity of the river. Cool. So now we can get this to say, hey, the distance going up is the velocity of the boat minus the velocity of the river. And I just kind of lucked out that, hey, we're really honing in on this form, but sometimes I won't, so we're going to go do it a different way too. Just keep that in mind. So this is going to be the time going up. Now we can kind of say the same thing for the velocity going down is proportional to the distance going down, and that's going to be hopefully equal to the time going down. And the same thing, well, we have to actually divide the distance going downriver divided by the velocity going downriver. That's going to equal the time going downriver. And so we know the velocity going downriver is just the velocity of the boat plus the velocity of the river. Hell yeah, we're going to increase in speed. So we have the distance downriver, velocity of the boat plus the velocity of the river is equal to the time downriver. Now, there's so many letters here that unless you played around with it, you know what I mean, hey, some of these might not make a whole lot of sense. But then we do know this total 4 hours. Hey, this is going to be the time going up plus the time going down. So that's going to equal 4. And so we have our equation. So we have, okay, so this plus this is equal to 4. So that's what you see. This plus that is equal to 4. And so I guess we can just write that out. We can be like du, the distance going up, velocity of the boat minus velocity of the river, plus the distance going down the river, velocity of the boat plus velocity of the river. And you can see how if we keep these in letter form, we could change. Like we could start at one point, go up river, but then just come down to like a picnic place, and maybe we know the distance of that, and then we know the time it took to get there. And then we could still figure out the velocity of the boat from that perspective. All right, so this is going to be equal to, and we're just going to say the time total is time up plus time down. So we're just going to say, keep this all in letters. This is just going to be time total. Sweet. Now, I actually didn't do, like when I first started this problem, I did like, what did I do? I think I chose like the speed. I said, hey, if I knew the speed of the boat going upriver, is this what I did? No, what did I do? Oh yeah, I think I did it straight on time. Did I do it on time? I have no idea. Alright, hell yeah. So here was my notes going into this, and yeah, so what I did was velocity in kilometers per hour. I said if I knew that, and then I knew the time in hours, then I would know the distance, like the distance going upstream. So I did it like this. I said, well, the velocity of the boat going upstream is going to be the velocity of the boat minus the velocity of the river, and then we're going to multiply by that by the time going upstream. And then that's going to give me, what does this give me? Velocity times time. That's going to be the distance. Cool. So then I'm going to say plus the velocity of the boat downstream plus VR times the time that it takes downstream. And then I guess I just said, hey, I can see that this is the distance upstream plus the distance downstream. Sweet. So I can say that this is going to be 40. And then I think I just used continuity saying, hey, the time upstream plus the time downstream was equal to 4. And then I could substitute in. So I said, hey, the time upstream is 4 minus the time downstream. It's just it's not as nice as this, but it still gets the job done. So we're going to say the velocity of the boat minus the velocity of the river times 4 minus the time downstream plus the velocity of the boat plus the velocity of the river times the time downstream is equal to 40. Now, and even here it's just like, well, how do I get rid of this times downstream term? Heck yeah, and that's when I realized it's like, well, maybe this wasn't the best way to go, and then this was adding too many equations, because we said that this was du and this was dt. So we have, the distance upstream is equal to velocity of the boat minus velocity of the river times time upstream. And we can say the distance downstream is the velocity of the boat plus the velocity of the river time downstream. And so if we wanted to solve this for time downstream, well, we would just say time downstream is the distance downstream divided by the velocity plus the velocity of the river, and then throw that in here. And if we did that, you would see that right in here, these would cancel, and we would just have the distance downstream. So let's see, and we know what those distances are, and we would do the same thing over here. So we would get VB minus VR, and this is just like show you, like, oh, it gets a little bit, maybe not nice, but we have the distance downstream divided by VB plus VR, plus distance downstream is equal to 40. So here we go, and we just don't know the velocity of the boat downstream. But these can get you the same places. What we could have done is we really wanted to factor out. So let's say if we did get it to this, it's just like, well, I really want to factor out a TU plus TD. And if I did that, I know that that's going to be equal to 4. But the only way to factor that out is to make these two things equal to each other. And the only way to make these two things equal is that you could multiply this side by VB plus VR. And then, oh, you can't do that. Never mind. Oh, no, you could. But you just have to multiply the bottom by VB plus VR. So, yeah, that's not going to work. Never mind there. All right, so I guess we just have enough here, even though it just looks hellish and not friendly. So what should we do first? I think what we should do is, ooh, this is brutal. You know what I mean? That's like so fascinating that you can kind of take two different routes down a problem, and one is just like the worst. But we'll stick with it, maybe. I mean, I guess at some point we're just going to have to factor things through, but I don't want to do that one. So we're gonna say this is 40 minus the distance downstream, and yeah, we'll keep it as is, and then we're going to oh, I don't know, I want to give up on this. All right, let's keep going. Everything is a constant except the velocity of the boat. We know the velocity of the river. We know the total time, and even this I shouldn't put 4 in here. It's just the time total. And then we know our distance downstream. Cool. And I guess we factored out the distance upstream. And basically we just want to get the velocity of the boat. So we would need to get this upstairs. We might as well factor this through. So we're going to have, and let's get some new sheets of paper. Alright, hell yeah. So I think we got our work cut out for it. I mean, we would have technically had to done the same thing here to get, like, hey, you can't just divide by x, you know what I mean? You have to get things upstairs. So you're going to do the same amount of work. It just seems like you're going to make more mistakes with this. But we're going to factor this through. So this, if we factored that through, I guess we'll just go VB minus VR times time total. And then we're going to go minus distance downstream, VB minus VR, divided by VB plus VR, plus distance downstream is equal to 40. Okay, so we want to get probably this on top. The way to do that, or just get it out of the bottom, is to multiply everything on this side of the equation and this side of the equation by VB plus VR. Cool. If we do that, then this will get multiplied by VB plus VR, and that'll just cancel. So in this part, it'll equal 1. Everywhere else, you'll just have another factor of VB plus the velocity of the boat plus the velocity of the river. So let's do this. So we got velocity of the boat plus the velocity of the river. That's what we're multiplying to this. Cool. And then this one just becomes distance downstream. Heck yeah. Then this is distance downstream, velocity of the boat plus the velocity of the river. And then we have equals to 40 velocity of the boat plus velocity of the river. Alright, heck yeah. So here we're going to we're going to basically do the FOIL method. So we have VB squared minus VR. That's just the constant, so we'll put it out in front. Times VB. And then we got plus VB. So we're doing now this one. VR plus VB. Those cancel, sweet. And then we have minus VR squared. Okay, all of this is still times time. And hopefully we can do this faster, so we can just do this one, and this one should be just a lot easier. Maybe it's the same amount of work, I have no idea. Alright, so now we have plus distance downstream. And then this is going to be plus distance downstream VB plus distance downstream VR is equal to 40 VB plus 40 VR. Okay, and I could just multiply everything by that time t in here, and so I'm going to have time total of 4 VB squared minus I'll do it like that, times the total time times VR squared plus distance downstream VB plus distance downstream VR is equal to 40 VB plus 40 VR. Alright, heck yeah. And even this 40 is just the distance total, but we don't want to go too crazy on the letterage. So if we have to get, so there's a velocity b squared, there's just a velocity b, and there's a velocity b. Everything else is a constant, and so now we can get it to where it's in kind of a quadratic equation. And so on this side, you're going to have a distance downstream plus 40, and that's going to be, or actually subtract, sorry. So you're going to have distance downstream subtract 40 VB. Cool. So that's going to be 20 minus 40. So we got negative 20 VB. So let's write this out. So we have the time total is 4. So for our quadratic, we have 4 VB squared minus 20 VB. And then for all our constants, we have velocity of the river is 3. 3 squared is 9. 9 times 4 is 36. So we got negative 36 there. We have 20 plus 20 there. This is going to be 3 times 20. That's 60. So we got plus 60. And then on this side, we have 40 times 3. That's going to be 120. So over here we have 80. And we're going to have to subtract 120. So we're going to subtract 120. That's going to be 156 plus 80. That's the same thing as taking 156, subtract 80. Now, this is negative. Keep that in mind. So we have 6 and then 7. So we have minus 76. Okay, so here's for our quadratic equation. We basically have 4 VB squared minus 20 VB minus 76. And I have no idea, you know what I mean, that was just a really difficult way to do the algebra. But you know what I mean, we stuck with it. I think that's a good skill too, just to be like, hey, it's going to work, just stick with it. But I almost guaranteed I made a mistake. Alright, so hell yeah. So let's just go back to this and like why does this work out so well? Is because you're kind of combining, you're saying, hey, the time upstream plus the time downstream is equal to 4. That's kind of your continuity. So usually with algebraic equations, you know what I mean, you have this kind of continuity that usually links things together. So I don't know. So in this case, I think just going for the continuity first and then being like, well, what are the units on this? Well, they're going to be units of hours. And then what are our units of our problem is going to be kilometers per hour. And then we have kilometers. So let's figure out how to find the time upstream. Well, that's going to be our velocity. No. It's going to be our distance upstream. Remember that? Because you're just like, if we have these two, how do you get hours? Well, you have to take this divided by that. Hours pops upstairs. So that's where you're going to have that 20 divided by the velocity of the boat upstream. But we know the velocity of the boat upstream is going to be the velocity of the boat minus the velocity of the river. So sweet. So now we have this equation for TU. So we could just say the time upstream is 20 divided by VB minus VR. That gives us maybe our second equation. And then you can say the time downstream is going to be 20. Hey, then the velocity of the boat adds to the velocity of the river. So maybe this is our third equation. And then you can just see how you can just go for it just so fast and then plug those in. And so this is the one that we're going to try to solve. And we'll do it like they do it, where you say the velocity of the river is 3 kilometers per hour, and then anything else? No, I think we're good to go. And then we already put in the distance up and down. We didn't say, hey, the distance upstream is equal to the distance down. You know what I mean? We didn't do letters for that. We just threw it in. Okay, so we have 20 divided by velocity of the boat. But we will keep this. Instead of x, I don't know, sometimes it's just nice to actually have a variable that you can kind of see. Alright, so plus 3, and then we got 20. Oh, I apologize. No, this is the upstream. It's got to be minus. So we got minus 3. Yeah, let's do, so we have 20 velocity of the boat minus 3 plus 20 velocity of the boat plus 3. This is equal to 4. Now, how do we get, you know what I mean? I think the first thing you want to do, especially with quadratics, is like, how do we solve for this? Well, you want to get this to the top. And so the easiest way is to get the denominators the same. And so we're going to go VB plus 3. Okay. And then this side we're going to go velocity of the boat minus 3 on both sides. So these are going to be 1. And then on top you're going to have, and we'll just FOIL it through, you're going to have 20 VB plus 60. And then over here you're going to have plus 20 VB minus 60. So sweet, the 60s cancel. And then just up top you're going to have 40 VB. Now downstairs you're just going to have it all over VB minus 3, VB plus 3. And since we've already done this a couple times, we know that when we FOIL this through, we're going to have VB squared, negative 9, but then the other terms will cancel. So cool. So we're just going to have VB squared. Oh, and then this is all is still equal to Oh yeah. This is still all equal to 4. Yeah, that still plays. Yep. All right. So we have VB squared minus 9 is equal to 4. Okay, heck yeah. So we got the denominator the same, and now we can bring that upstairs in this equation. So we're going to bring this upstairs, and we're going to VB squared minus 9. And so now we're going to have 40 VB is equal to 4 VB squared minus 36. And what did we get? Were we fairly close? I don't think so at all. So we got the 4 VB. We got minus 36. But no, we were off by a factor of 2. So yeah, somewhere I probably made a mistake. So we're just going to move on from that one. Unless I made a mistake on this one. I don't think so. Because this was going to be 20 VB plus 20 VB. So that's 40. And then 60 minus 60. Those cancel. Here we have VB squared. Because we have the same denominator. VB squared, velocity of the boat squared, minus 9. And then the middle terms cancel. Cool. So we have 9 times 4 is 36. Heck yeah. So let's just solve this one with our quadratic equation. Alright, so we're gonna write this down as we're gonna have 4 VB squared, and then we're gonna say it's minus 40 VB, and then minus 36 is equal to 0. So we just got this term over here and set everything equal to 0, and now we kind of have that classic ax squared plus bx plus c is equal to 0. So in this case, we have our a term is 4, our b term is negative 40, and our c term is negative 36. But what we wanted to do is not use the quadratics. We'll use those two that we used in this video to double check our answers. But what we want to do is just do what we would do to solve this. So we're going to divide by 4. So that's the first thing. So we're going to have VB squared minus 10 VB. Now we can even do 2 steps at once. We're going to do 36 divided by 4. I don't know what that is, but divided by 2 is 18. And then divide by 2 again is 9. Okay, sweet. And that makes sense. 4 times 9 is 36. So we're going to have negative 9, and then I'm going to add it to the other side. So I'm going to say, hey, this is just positive 9 on the other side. All right, heck yeah. And then so now we're going to square this. So we're going to have VB. And we do have a negative here. So we're probably going to have a negative. And then this has to be half. So maybe it's 5. You know what I mean? So maybe it's 5. There you go. So let's see if that worked. So we're going to have VB squared plus 25. And then when you do these, it's going to be negative 5 VB, but times 2. So it's going to be negative 10 VB. Sweet. So we have those two terms and those two terms. We just got to add 25 to both sides. Yeah, I don't know why I've never done this. This is so fascinating. You know what I mean? This was kind of what I wanted to do this video. Sorry it took so long to get here. But hell yeah. So now now this side is true to form if we added 25, and this is going to be basically 35, 34. So we're going to have that. We're going to take the square root. We're going to get plus or minus, and the square root of that, and then we're just going to add 5. So VB is plus or minus the square root of 34 plus 5. Cool. And even just right here, hey, what's the square root of 34? I don't know. The first thing that popped in my mind was like square root of 25 is 5. Oh, but what's the next one? Oh, that'd be the square root of 36 is 6. Okay, so this is pretty close to 6. It's not 6, but let's just say it's 6. Plus or minus 6 plus 5. So this gives us, hey, let's do this. 6 plus 5, that's 11. Cool. And then negative 6 plus 5, well, that's negative 1. Like, obviously, the velocity of the boat can't be negative. It's fascinating that that's a solution, to the problem. Algebraically, it's a solution to the problem, but in a real-world example, I'll have to take a look at that one. But yeah, it's totally nonsensical. The velocity of the boat go in just the opposite direction. Like how yeah, how can it actually get upstream? It can't get upstream. But yeah, it's just fascinating. That's some things are nonsensical when you do the quadratic equation in real life. Okay, and hell yeah, so we did it. And we see that our speed is really close to 11. Could we figure out if it's less than 11 or greater than 11? Because if this was 6, square root of 36 is 6, square root of 34 must be less. Let's just say it's 5.9, you know what I mean? And so we have, now we have plus 5.9 plus 5, and we have 10.9. So we think our answer is pretty close to 10.9, and now we can just get an official answer. Square root of 34 plus 5 is 10.83. Cool. And now it rings a bell, because what did we put in our calculator? Our calculator says 10.83095, and so we were just on our way to solve it. Hey, so we did a pretty good job. So it's just fascinating how some of these are fairly easy to solve intuitively, but then when you get to set up the quadratic, and I'm glad I kind of ran into that stumbling block, you know what I mean? Because that's what I wanted to do. It's just like when I got this problem, I kind of went down this route. And then I was just like, well, how did they actually make it so simple? And then I just realized, yeah, I get how there's always a way to make the problem simpler. And for this, it was just instantly start with that, what do we call this? It's like a continuity equation. It kind of it's basically what makes the problem function. You know what I mean? Hey, we have a time upriver and a time downriver. Those two times are going to be different, but at least we know the total time. And then away you go with this equation. All right, so that was pretty sweet. So now what we're going to do is see if we can. And then it's just fascinating that I made a mistake. So somewhere in here, this just got too ugly, and yeah, I made a mistake. You know what I mean? So I don't know if I could even catch my mistake. So this is going to be 4. We got that. Oh, yeah. And so this is going to be 4 times 9. So this is going to be negative 36. Negative 36 there. Plus 20. So we'll just keep going. So that's going to be negative 16. So now we're up to negative 16. And then we're going to add 20 times 3. Add 60. So if we had negative 10, add 60. That's going to be 50. But we're going to have 6 less. So we're going to be up to 44. So now we're up to 44. And we're going to subtract 120. If I had 40 subtracted 100, that's going to be 60, negative 60. But then I'm going to subtract 20 more. That's going to be negative 80. But I had 44, so I have negative 76. So yes, my error is not here, that's for sure. So my error is somewhere else, and I just don't want to find it. Anyway, but what we are going to do is we're going to take this quadratic, which is 4, basically just 4x squared, minus 40x minus 36 is equal to 0. And we're going to take this generic ax squared plus bx plus c is equal to 0. And see how fast now we can get there. All right, heck yeah. So now I can just instantly see, hey, this is going to be, can I do this all in one step? You know what I mean? Hey, I'm going to bring the c over here, divide by a. So I got negative ca. So let's just do that. Negative ca. And then I got to complete the square. I'm going to have, I need to have a term that's b. This is going to be divided by a, right? So I'm going to have a term that's ba, but I need 2 of them, or half of them. And so I'm going to have b divided by 2a. And then plus x. And then when I square that, I'm going to get a b divided by 2a squared term on both sides. And then I'm going to get plus or minus. To get this over there, I got negative b divided by 2a. Hell yeah. So now, if I throw this in, then I can say, hey, we have negative 36. That's going to be 36 divided by 4. That's going to be 9. So sweet. So I have 9 plus, I'm going to have negative 40 divided by 4. That's going to be negative 10. And then I got to divide by 2. That's negative 5. And then square it. Sweet, that's just 25. So perfect. I got 25 there. And then I got plus or minus 9. And so this is going to be the square root of 25 plus 10 is 35. But this is 34. And then b is negative 40. But I got negative 40. So I got plus 40 divided by 4. That's 10. And then divided by 2. That's 5. So plus 5. Heck yeah. So this is going to be my velocity of the boat using, using that equation. Now, if I just knew what the quadratic was, but I mess it up all the time. It's negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So now we can do the same thing. We got negative 40, so that's going to be 40. Plus or minus the square root. We have 40 squared. 4 squared is 16. Don't forget about the 2 zeros. That's the huge, When I do this, I'm just like, hey, what's 4 times 4? 16, and then I see just 1 0. And so that's where I make my errors. So it's 16, but 2 zeros. Cool. Minus 4. 4 times 4 is 16. But we have a negative. We got a negative 4 times 4 is negative 16. Times a negative 36. So we're going to have a positive, but we have 16 times 36. No one wants to do this, but we got 36 times 18, and we got 6 times 3. So we have 3. This is 8 plus 2 is 10. So we have, plus 4. So, cool. And so we have 543. 543. Holy Toledo. Yeah, so this is where this just gets ugly as, you know what I mean? Oh, this really shows, yeah, like, forget the quadratic equation, you know what I mean? Life would be so much easier if you use this, because you can see how things simplify so much easier. If you got a calculator, heck yeah, use the quadratic. But, man, this just gets ugly fast. So, alright, so we got to go 5 here, and then 10, and then do a 9, and then 10. So we got 7, 5, 0, 1. So that's 1,057. Could we have done that pretty easily? If this was 1,600 minus 500, that would be 1,100. But then we got to maybe kind of minus 50. That would be 10,050. But we didn't minus 50. We just minus 43, so it would be 7. Hell yeah. So that's a double check on reality. And sweet. So we have this is the square root in there. So we have 40 plus or minus that. And then 2 times a is 8. So yeah, this is super ugly. But we have 40 plus the square root of 157. Now, you got to remember this is all divided by 8. And this is going to be 9.06. See, like I made an error. Isn't that crazy? You know what I mean? I'm cursed with the quadratic equation. Yep, totally cursed. So we're going to do it one more time and go a little bit slower. All right, hell yeah. Yeah, no, I every time I can't do the quadratic with getting it right. I think it's due to the negatives, and I just kind of make the same error every time. Okay, so here is our quadratic that we want to solve. The quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so we have negative 40. So x is going to be 40. Plus or minus, we're going to have b squared. So that's 40 times 40. That's going to be 16 2 zeros. Cool. Minus 4 times 4. And this negative went away, so we squared it. Cool. But we're going to have negative 4 times 4 times negative 36. Sweet. So this is going to be 8 times 36. So we have 36 times 8. What is this? 54. See, I might be just doing those things wrong. What's 8 times 6? 5 times 8 is 40. So 6 times 8 is 48. Yeah, so mess that one up. Yeah, 6 times 8. Holy Toledo, that's a tough one. Yeah, 5 times 8 is 40. Got that. Plus another 8. Cool, 48. All right, and so we have 24, 25, 26, 27, 28. So we have 28. And that's it. So it's 288. So yeah, I bet you I messed up that. So let's check the error. Where did so I said this was going to be 16 times 36. No, it is. Yeah, this is wrong. So it's, yeah, holy Toledo. So 4 times 4 is 16 times 36. So we got to do this. I'm probably messing this one up. So we have 36, 18, 19, 20, 21. And then we have 36. 6, 7, 5. 5, 7, 6. Yeah, so that is not what I got. Yeah, it's fascinating. It's good to double check your errors. So I did 36, 36, but then I just did 18. I forgot to add those other 3. So my bad on that. But heck yeah. But still, this gets a little ugly. So this is still negative. No, and this is adding. Oh, that is crazy. Because even over here, once I got this number, 1,000. Oh yeah. So yeah, I'm cursed with this quadratic because just the way it lays it out. So, like, do you solve for 4ac and then subtract it? Or do you solve for negative 4ac and then remember to add it? Because, holy Toledo, I'm making every mistake you can on the quadratic. So at least if I make all the mistakes, you can definitely see. So, heck yeah. So we just did negative 4 times ac. You know what I mean? So this is, you could say this. I mean, maybe I should write the quadratic like this. Negative b plus or minus the square root of b squared plus negative 4ac. This would actually help me so much because I just feel like I want to get this part out of the way, but then when I get that value, then I just look at the equation and then subtract it again. All right, so we got to add 5, 7, 6. And so if we do that, 1600, 5, 7, 6. This becomes 11. So that's 2, 1, 7, 6. All right, square root of 2, 1, 7, 6. So we have 40 plus or minus the square root of 2,176. And then divided by 2a, which is 8. And I don't even know if I actually did this right. So we have 6, 7, got that. 5 times 6 is 11. Cool. And then so how would we know that this is actually, like, we could simplify this? I don't know. Let's work on that. Because I might have made a mistake anyway, but we're going to take 2,176 divided by 2, and we get basically this 8 plus remainder 8. Okay, so we get 1,088. We can divide by 2 again, and we're going to get 544. Sweet, so we can factor out a 2. So this is 2 square roots of 544. So that's what we just did. We said, hey, this is going to be, this number is going to be 2 times 544. And then we took the square root. And remember our rules? We can say, hey, that's the square root of 2, square root of 2, square root of 544. We know that these two add up to 2. So hell yeah, so that's what we did there. So I think, yeah, we're adding little tidbits to this video that are really useful. Okay, so now 544 divided by 2, we got 2 of them, and we got 7, and then we got 2. So we got 2, 7, 2. At least we can factor out another 2. Heck yeah. And so we have 1, we're going to have 3, and then 6. Sweet. So now we have, we can do that same thing, how 2 square roots of 544 is the same thing as 2 times the square root of 2 times the square root of 2. Sorry. I'm doing too many steps at once. But this is going to be 2 square roots of 2 times 136. Cool. So now you can turn that into this. Heck yeah. And so now once you do that, then you can, you got a factor, you got another 2. So now we got 4 square roots of 136. Heck yeah. And we'll keep going. So we got 136 divided by 2. That's going to be 6. And then 8. So we have 68. Sweet, we can do it one more time. So divide by 2 is 3, 4. Sweet. So now we know that this number, 4 square roots of 136, is equal to 4 square roots of 2 times 60, times 34. Holy Toledo. So heck yeah. So this is going to be 4 square root of 2, square root of 2, square root of 34. And then heck yeah, we got another 2. So now we have 8 square roots of 34. And so we'll keep on going. I think this might be the last. No, we can factor out another one. So we have 34 divided by 2 is 1. No, that's it. So we have, so we're down to the square root of 34. Oh yeah, and I remember that because we were thinking like 36. You know what I mean? It's not 36. It's not square root of 25. Closer to 6, farther away from 5. It's probably like 5.9, but it was actually 5.8 something. Cool. Yeah, and so the square root of 34. Always good to play around with the numbers. It's 5.83. All right, heck yeah. So we really simplified this down. And then what is our number out front? Did we totally mess that up? No, we have 8 square. Oh, so perfect. So this is going to be 8 square roots of 34. And then even this, hey, this is the same thing as 40 divided by 8. That's going to be 5 plus or minus 8 square roots of 34 divided by 8. That's just the square root of 34. So hell yeah. So we could have just thrown this into our calculator as 40, do parentheses first, because we got 40 plus the square root of 2176, and then all divided by 8. Cool, so that's going to be 10.83095. Or you could, and the same thing as this, 5 plus square root of 34. All right, same answer. Okay, so we did this 3 ways. I did everything I wanted in this video. It's probably hella long, but still, it was pretty interesting. So I'm glad I did it, because actually this is the first time ever that I've ever taken just a normal polynomial, that's x squared, and then just, instead of deriving, like in the same amount of time that you derive how to figure out how to solve the generic ax squared plus bx plus c is equal to 0, I never knew that, yeah, I could just, hey, divide this by 4. Divide this by 4. Get this the hell over there, plus 36 divided by 4. And then complete this square. That's going to be negative 10x, so then I'm going to have x minus 5x. X minus 5. But I'm going to get a term here that's going to be, that I don't have, that's going to be a plus 25. I don't have a plus 25, so let's add plus 25 onto both sides. Booyah. And so I have the, then I can take the square root of all that, and then subtract whatever was in here, but that's just going to be plus 5. Cool. So heck yeah. So I have 9 plus 25, square root of that, plus 5. So heck yeah. So I can just, and that's good. It's just like, it's good to do, go through it slowly and then just whip through it. You know what I mean? Because you shouldn't move on to other problems, because you can just do the same problem in just lightning speed and you can totally see it. So it's the square root of 34 plus 5. So heck yeah. So there you go. So I just did that one. And now I can even just do it even faster. Hey, I'm going to divide negative 36 by 4. That's going to be negative 9. Let's get over here. That's 9. And then I have 9 over here. This isn't a complete square. It might be, but it usually isn't. Or actually, it probably can't be. If you have just an x squared plus or minus any x, it can't be a complete square. Yeah, so no duh. But then we're going to have, and this is negative 10, so we're going to have a negative 5, negative 5 squared, so that's going to be this 9 plus 25, that's going to be 34, so we have and then we're going to take the square root of that, square root of 34, and this was x minus 5, add the 5, square root of 34 plus 5. So it's just fascinating that you can just kind of talk through it too, so then you don't have to actually throw anything down on paper. But it's only at this point when you've worked it so much that you can probably talk your way through it. Because if I just got this for the very first time, hell no. My brain would be willing to try to keep all those numbers and not mess them up. Okay, so heck yeah, so we did it. And what did we learn? Because that's the other thing, is we learned that, you know what I mean, if looks like our boat is going about 11 kilometers an hour, cool. And so yeah, so if we have this, 5 plus the square root of 34, this is our speed now stored as x. On the way up, it's going to be minus 3, so our speed is going to be 7.83. 20 divided by that is going to take 2.55 hours up, and then on the way down, 20 divided by x plus 3 is going to take 1.45 hours on the way down. So now we actually have roughly how long the trip's going to take. If we got to go upstream, it's going to take 2.5 hours, and then just a little bit over 1.5 hours coming back. You know what I mean? So 2.5 hours going up, and 1.5 hours coming back. Sweet. All right. So yeah, you should always do that. It's just like, what did we just do? Like, cool, we got a number in a very technical way. But there you go. So now we know kind of what the problem was all about. All right. Thanks for joining me, and that's a video.